the inverse of a 2 by 2 matrix. The inverse of the matrix A is denoted as A minus 1, and note that doesn't mean 1 over A, as when we were discussing with trigonometric identities and things. The minus 1 here means the inverse, and note that they're inverses of each other. It is a matrix such that if we do A multiplied by the inverse, or the inverse multiplied by A, in either case, we get the identity matrix. So this is a situation where AB is equal to BA, if you like. So consider A as being the matrix ABCD. And what we're going to do is work through and see if we can find the inverse in terms of A, B, C, and D. And in order to do that, we're going to consider that the inverse is this matrix here. So what we're being told is that A, B, C, D multiplied by P, Q, R, S is equal to 1, 0, 0, 1. Well, let's do this multiplication. So I'm going to have AP plus BR, that's my top left, AQ plus BS, and then CP plus DR, and then CQ plus DS, and that's going to be equal to 1, 0, 0, 1. So we have AP plus BR is equal to 1. AQ plus BS is equal to 0. CP plus DR is equal to 0. And CQ plus DS is equal to 1. So let's see what we can do with these simultaneous equations. Let's first of all see if we can isolate P. So we've got P in this equation and we've got it in this equation just here. So we need to get rid of R. So if I do equation 1 and multiply that by D, I get ADP plus BDR is equal to D. And then multiply 3 by B. And then I get CBP plus BDR is equal to 0. Now we can get rid of R here. So subtracting gives me ADP minus CBP. Probably should put those the other way around. Let's make it BC, so they're in alphabetical order, is equal to D. So factorizing out the P, we get AD minus BC is equal to D, and therefore P is equal to D divided by AD minus BC. Now we can actually repeat the whole process for each of the P, Q, R and S, but That's going to take a long time, so I'm just going to say what the result is. We've seen how it works for P. So what happens is that the P ends up being, as we've got over here, D over AD minus BC. It turns out that Q ends up being minus B over AD minus BC. The R ends up being minus C over AD minus BC. And the S ends up being A over AD minus BC, which we can write as 1 over AD minus BC into D negative B negative C A. Now if you look at what's happened here compared to this matrix, first of all we have this A multiplied by D, that's the leading diagonal multiplied, take away B multiplied by C. This is something known as the determinant, and it's really important. The determinant of a matrix is AD minus BC. And in the case where the determinant is 0, we can't divide by 0. That means that matrix has no inverse matrix. So it's really important. Don't forget the determinant. Then once we've done that, you can see that A and D have switched positions. A's gone here and D's gone here. And the B and the C just have the negatives taken. So it's really easy, once you know this pattern, to find the inverse of a 2 by 2 matrix.